Alright, we're going to be looking at study 6. It is two objects connected together. Object 1 on the horizontal surface has friction. Object 2 on the incline has a frictionless surface. Our job is to find the force of friction given the acceleration of the system. So we can immediately write down that acceleration is a given, and we want to find the frictional force. That's our unknown. Let's start by drawing a free body diagram for mass 1 and identifying all the forces that are influencing mass 1. Pause the video and do this, and then resume the video. Okay, so let's start with our free body diagram for mass 1. Alright, so we have normal force acting upward. We have the force of tension, label that Ft. We have the force of gravity on the object, mg, which we'll call F sub g. And then we have the frictional force acting in the direction opposite the motion. And we are assuming that our acceleration is in this direction. Remember that our acceleration is our given. We will set our xy axis so that y is aligned along the normal force and x is aligned along the direction of acceleration. Now write down the component equations for Newton's second law for mass 1. Pause the video, take a few minutes and do it, and then resume the video. Alright, so the component equations, we have the sum of forces in the x direction will be equal to the force of tension minus the force of friction will be equal to mass 1 times the acceleration. For the y direction, we have the sum of the y forces equal to the normal force minus mg, and since it's not moving in the vertical direction at all, that of course is 0. And then we have one more relationship we always have to be mindful of. If we're going to find the force of friction, what is the relationship of the force of friction, the coefficient of friction, and gravity, and the normal force? Well, we know F is equal to the coefficient of friction times the normal force. From the y component equation, we know that the normal force is equal to the mass 1 times gravity, and so my frictional force will be equal to the coefficient of friction mass 1 times gravity. Now let's look at object 2. Let's draw a free body diagram for object 2. Pause the video, go ahead and draw it, and then resume the video when you're done. Okay, free body diagram for mass 2. Well, let's start over here, and we have a normal force, and remember that the normal force is perpendicular to the surface of contact. So normal force is going to act in this direction. Then we have the force of gravity. Alright, and that's just going to be m to G. And then we have the force of tension in the rope, and that's going to be acting up in this direction. And that details the forces acting on M2. Since we claimed it to be a frictionless surface, there is no friction acting on M2. What about my axis? Pause the video, draw what you think will be convenient axes, and then resume the video. Okay. For my axes, I will align my y-axis along the direction of the normal force, and I will align my x-axis along the direction of acceleration. Now, what I want to do is write down Newton's second law in component form for mass 2. Pause the video, write down Newton's second law in component form, and then resume the video when you're done. Okay, so let's now look at Newton's second law for this set of objects, for this particular object. Alright, so we have the sum of the forces in the x direction will be equal to minus Ft plus M2 G sine theta will be equal to mass 2 times acceleration. For the y component, we have the sum of forces in the y direction equal to Fn minus M2 G cosine theta equal, and there is no movement in the y direction, so that's 0. Now, you should be able to understand where the sine theta came from and the cosine theta. Okay. If I extend my axis in this direction, the theta we're working with is this theta right here. That is the same as this theta right here. As we can see, that this component, the y component, or the x component will be the sine of the theta, the y component will be the cosine of the theta, cosine of theta. Okay, now I have that, or two equations for both objects. For Fy, the y component, I have that Fn is simply equal to M2G cosine theta. And since there's no friction, there's no frictional force on this object. The two x component equations both contain the acceleration, and that's what connects object 1 to object 2. So let's write down the previous equations that we had on a new board. Okay, we've written down our equations relating the acceleration of object 1 and the acceleration of object 2. Both have the force of tension in it, and we can obtain the acceleration or the frictional force in terms of the acceleration of the object. So let's do this. Let's add equation 1 or equation 2 or to equation 1. So I'm going to put under here sum of Fy equal minus Ft. Now we can always add two equations together. We just add the right hand terms together and the left hand terms. Plus m2 g sine theta will be equal to m2a. Now, notice we can get rid of the tension force, and we have minus F plus m2 g sine theta will be equal to m2a plus m1a. And the frictional force, we remember that F is equal to mu Fn, which will be equal to mu m1g. So we have minus m1g mu plus m2g sine theta will be equal to m2 plus m1a. And we can either find the coefficient of friction here, or we could have solved for F directly. So if I wanted to solve for F, I could just simply say that minus F equal to m1 plus m2 quantity times A minus m2g sine theta, and there I have F solved for. Then once I have F solved for, I can come up here and solve for the coefficient of friction mu. So if we had said that A was equal to 2.0 meters per second squared, m1 equal to 5 kilogram, m2 equal to 5 kilogram. We know what G is. Let theta be equal to 30 degrees. And then we could substitute our numbers in. Substitute our numbers in, and we'd have 5 kilogram plus 5 kilogram times 2 meters per second squared minus 5 kilogram times 9.8, and of course times sine of 30, and that's going to be equal to a minus 4.5 newtons. And since we know that F is equal to 4.5 newtons, that means that that's going to be equal to mu times mg, m1g, which that is equal to mu times 5 kilogram times 9.8, and we can solve for mu, and that's equal to 0.1. End of problem.